Okay, I think seeing my mug once per lesson is quite enough. All right, so this next video is from the Fox Sports science team. Let me put in science here so that we can make sure that we get our because believe it or not, this is going into kind of a platform book or textbook type, not a textbook, a traditional textbook, but for the top hat folks. And so we got to make sure our copyright stuff is correct, and that we're not like all my little Homer Simpson things and stuff. I've got to clean those up before we go to the real press, because that causes all kinds of Matt Groening of the creator of The Simpsons might get upset with me. I might, break into the billions of dollars he's made off that franchise over the past 30 years. But anyway, what you're going to see here, right, is it's cheerleading is dangerous stuff. All right, it's one heck of a sport, and of course these Fox Sports science people get kind of dramatic with everything, which is fine. But here's the big idea that we're going to do is, in other words, we're going to convert gravitational potential. And like I said earlier, this is enough for the first video. Now for the second video that I'm going to do, let's run through how we would solve, like how fast. In fact, I think we have a slide on it right here. That we look at LeBron James, and we're going to find out how, if you're going to jump from a 10-meter high board, how fast are you going to be going? Or if these girls jump from a height of 18 feet, I think it's 18 feet and not 15 feet that I have in there, you'll see how high we're going, and we're not going to look at the skateboarding stuff. I'm sorry. There's this, to me it's like, whatever. All right, and we might look at the ramps in the next. No, we'll look at ramps in this one too. So you probably won't see any skateboarding things, but we're definitely going to see cheerleading and football. Now here, and I'm also going to show you the hammer and feather drop thing. All right, but here's what we're doing. We're going to say how quickly, how fast, how do we calculate the thing? Now, if you just saw this, if I just published this for you raw, you'd be like, what the heck is this? You're killing me. All right, let's go through it here. All right, so here's what we're doing. We're going to be taking gravitational potential energy, because it's got potential energy. It's ready to do work. And we're going to change it into kinetic energy. Because that's what you do. If I take this pen and I drop it, boom. It went from potential energy to kinetic energy. So I'm going to have, let's say I've got a cheerleader at 18 feet high. So the height is 18 feet. Well, the first thing I do, because I'm lazy, I would go to Google here and go, 18 feet is how many meters? Oh, 5.4864. There we go. Got that. Now, I don't know if that's what you're using or not. I've already forgot what it was. 5.684. Or is it 4.46? Okay, I'm going to drive you. I know I'm driving you completely out of your gourd right now. 5.4864. 5.4864 meters. All right, so that's how we're going to go. All right, so, and let's say we've got a 60 kilogram mass is let's say a 55 kilograms, because these cheerleaders, they're small, as you're going to see in this video, and the cheerleaders are getting smaller because we like to throw them around, and it takes a lot less energy to throw them around. Okay, so they got a mass of 55 kilograms. We're going to find out that the masses cancel, because when she's at 18 feet, she's got mgh is equal to 1/2 mv squared. Where again, this is gravity, the height, and the velocity. And we want to find out v final That's what we call it. V final. Sounds like vinyl, but it's V final. Speed when hits the ground. Okay, that's what we're going to find, and this is our V final right here, because Dr. Kruger, who invented this, who came up with this slide, he didn't invent potential energy, gravitational potential, but he's the master of it. But anyway, so you've got mgh initial, which is at the maximum height. Mgh final is equal to 1/2 mv squared final plus 1/2 mv naught. So initial height is at 18 feet. So we've got mg at 18 feet, which is 5.864 meters. Okay. Height final is 0. So that just goes to 0. Is equal to 1/2 mv final squared plus this guy goes to 0 because the initial velocity when they started off was 0. All right. So we're just after, but notice I've got an m on both sides. I got a mass on both sides. I can divide by the mass over here, and I can divide by the mass over there. All right, already some of you are going, oh my God, this isn't what the hell I signed up for. You're doing algebra. I hated algebra. Oh, come on. It's not that bad. We're just dividing two things out of each other. Okay? That's all. If I've got an m on this side, I can just cross them out. Bye, Felicia. Okay? There we go. Right? It's gone. So I've got G times H. And in physics, we do everything in letters first before we go to numbers. So my masses are gone. So I got 1/2 V final squared. Now, what do I do here? I want to get rid of this guy. So if I multiply him by 2, great, I get a 1. Oops, got to make sure I multiply by 2 on this side. 2G H initial is equal to V final squared. Oh, man. But what's the square root of V final squared? That equals V final. Oh, but if I do it on this side, I got to do it on this side. Square root of 2GH naught is equal to V final. And that's and you plug in your numbers, whatever it comes out to be. So this would be 2 times 9.8 times 5 and then you take the square root. On my calculator, I can do it all in one shot. Okay? On my calculator, because I'm special, I can do it like this. I can go the square root of 2 times 9.8 times 5.4864. Now make sure it's 18 feet because it might be 15 feet that they had her up in the air. That's about 10.3 meters per second. Now if I divide that by my quick and dirty conversion, that's about 23 miles an hour. She hits the ground. Bam! And it's not the fall that kills you, it's the short stop at the end, and we'll talk about that later.